Welcome to Gradcast, the official podcast of the Society of Graduate Students at the University of Western Ontario.
Hello everybody and welcome to Gradcast, the official radio show of Society of Grad Students here at Western University. I'm your host Jina and I'm here with Alex. How is it going, Alex?
Pretty good. How are you today?
Not too bad. So, anything exciting during the weekend?
I went home to Toronto and I watched like an entire TV series, so that was cool.
Oh.
It was nice to see my family. That was good. But I'm actually a little more excited about that epic theme song we just had. That was, I think, the most epic intro Gradcast has ever had. Do you agree?
Yeah. No, it was cool. Thanks, Tristan.
Thank you, Tristan. Anyway, how was your weekend?
Good. I went to Port Stanley on Friday, which was nice, but we had not so great weather during the weekend. So yeah, I stayed home. So yeah.
How do you like Port Stanley?
It was really nice, really cute. Small town, but cute beach.
Did you see like the jail cell that they have there? There's like a really old jail cell outside. It's one cell, and
What?
you can like go in it. Yeah, it's really cool.
No.
Yeah, there's a plaque and everything.
Really?
And then there's this huge mural, because there was a big jazz club there, apparently in the 1920s and 30s, where people, like big famous jazz musicians from Detroit, would actually come across the border to perform at Port Stanley. It's called like the Stork or something like that. It was really cool. So everyone should go check out Port Stanley and look at this beautiful mural, which is like a testament to this jazz age club that used to be there, and the jail cell.
Oh. Okay, for
Fun
next
facts.
time. For next time.
Fun facts with Alex on Gradcast.
Anyway, so we're actually here with our guest, Jessica Blom, an MD PhD student. Hi, Jessica.
Hi.
How's it going?
Good. Thanks for having me.
No worries. Let's move on. Let's just start with a little bit of your background. So we hear that you completed your bachelor's at University of Guelph.
I did.
And then went over to Scotland to do your master's, and now you're here at Western to do your MD PhD, which is really exciting. So tell us a little bit of how you moved from Guelph to Scotland and then here in London.
Yeah, well, I guess it's been quite an adventure. I started at Guelph in the biomedical sciences program there, and I always wanted to travel abroad and have the experience of living abroad because I love traveling and experiencing different cultures and things like that. So I thought a great way to do it would be to do a degree in another country.
Wow.
And I was always interested in cardiac science and other biomedical related fields, so I thought, okay, I'll look into doing something related to that overseas.
Yeah.
So, yeah, that took me to Scotland.
That's exciting.
Which was great. I highly recommend anyone go overseas for school. It's a really great experience. But yeah, and when I was at Guelph, I actually had a presentation from an MD PhD student from Western talking about the MD PhD program. And it sounded like something incredible, and I thought I would never be qualified, but then I was, and so I applied.
And now you're here with
And now
us.
I'm here, yeah.
That's great. So, what made you move over to Scotland? Like, it must have been a huge transition, just different country, different culture. Can you share a little bit about that?
I totally know the answer.
Oh.
So, I've been to Guelph a few times, and it always reminded me of what I imagine Ireland to be like. So, you were in Guelph, and then you said, well, I kind of want to go to somewhere like Ireland, and then checked out Ireland, and were like, well, Scotland's right across the way. And I'll go there. Is that totally how it happened?
Maybe. They do have a big Scottish history department there. But no, I actually just looked into programs in English-speaking countries because I'm scared of other languages. And I found that the programs in Scotland were sort of what I was looking for. They have some great programs where you can experience research in a variety of different labs or with different professors instead of just with one. So you got a more broad spectrum experience in that program specifically. So yeah, that's what brought me there.
Did you meet a lot of other Canadian students there or other students from abroad. It was University of Edinburgh, right?
Mm-hmm.
So actually a person in my program right now did the same thing as you, and she's doing her PhD right now in neuroscience. So I was just wondering, did you meet a lot of other Canadians over there?
Oh yeah, actually I met a number of other people from a whole bunch of countries. It's a very, very international city, and it's wonderful for meeting people because everyone's very open to, meeting all these new people, making all these new friends. And I only became close with 2 Scottish people, actually. The rest were from all over Europe and Canada and the States. So it's very international.
Did you get to travel to other European countries then while you were there to visit friends?
I actually, I did a lot of touring actually in the Scottish Highlands, hiking up the Munros, they call them, the small mountains there, which is a wonderful experience. But yes, it's very easy to travel within Europe once you're there, so I did do some touring around. And I have friends from other countries there, so I got to visit them in their home country, which was great. And
wow.
They tour you around, which is always the best.
Very nice, very nice.
Yeah.
So we're kind of coming back to the MD PhD. So it's such a huge commitment, 7 years long. So what got you interested in doing this dual degree?
Yeah, it's definitely commitment, that's for sure.
Mm-hmm.
I think about how old I'll be when I graduate. But no, I think it's definitely worth it. I was interested in pursuing a medical degree for a long time. I kind of always knew I was interested in medicine, but I never knew when I would sort of approach that. And so it just so happened to be after my master's degree. But it was during my master's that I realized that I also enjoy research. And so the question was, how could I combine those 2 fields? And so the MD PhD for me was the perfect opportunity to do so. And
what's the structure of that program?
So at Western, there's 2 different structures that you can follow. I personally am doing what's called the 232 stream, where I complete the first 2 years of medical school, which I've done already, and then take a sort of leave of absence from medical school and take 3 years to do my PhD, and then I'll go back to medical school to complete the last 2 years clerkship and the clinical rotations. But the other way you can do it at Western is to do your PhD first. And then once you complete your PhD, do the entirety of medical school in one go.
What made you decide to do 232 as opposed to 3 and then 4?
Good question.
I have heard a number of people that I know that are doing the same program say that it might have been a good idea when they were starting to have done the PhD first so that they could start and finish with the same group of people. But at the same time, maybe it's like a bit of a break from all the coursework. So, yeah, what made you decide?
That's a good question. Actually, a lot of people struggle with what they're going to choose when they start, and I ended up emailing a number of the current students when I first applied to sort of figure out what I wanted to do. So if I can sort of put a general twist on it. So I guess the reason that I chose the 232 was because, first of all, I had completed my master's degree already. So I already had research experience, but it wasn't in the field that I'm currently in, and it wasn't at this school. So transitioning back would have been more graduate experience, but with the same knowledge I already had. Whereas if I did the medical portion first, I had a different background that I could apply to my current research. The other thing is that when you come into the research program after medical school, you have some time to get to know different laboratories or different research professors at the school that you're in. So I spent some summers in the lab I'm in now already, and getting to know the lab environment and the professors you're working with is important when you're going to start a PhD. You want to know what you're getting into. So that's another thing. And the third thing is that when you apply for funding, if you have those the medical experience behind you and the 2 summers of working in research, you might have more of a background in your research project, so it helps when you apply for funding. That being said, all of those things can be combated with the fact that you have to split your med school class. So the med school class, when you start, becomes like a giant family, and really everyone spends so much time together, not only in class but also with all the extracurriculars everyone's involved in, and everyone really supports each other because those are your future colleagues. So I am splitting my med school class, which is in one way great because I get to meet a whole bunch of new people and I'll work with a whole bunch of new people. And in the other way, it's difficult because I see all my colleagues moving on and entering the clinical setting, but I don't get to do that yet. And so And also the reverse applies if you're going to do the medical portion afterwards, then you have your PhD knowledge behind you, and you can then continue with new research projects during medical school that maybe were related to your previous project or are different, but you apply the concepts that you've learned. So it's really more what you're looking for. For me, I did my master's degree first, and so I was ready for a bit of a change, and I thought I could learn from the medical program, beforehand.
So for the future MD PhD students, which stream would you recommend?
I think it just really depends on what your past experience is, and if you have a lab that you're working in already and you're going to continue working in that lab for your PhD, it might be advantageous to stay and continue what you're working on at the moment. But outside of that, I mean, there's so many other factors that apply, so it's really a personal decision.
So the PhD portion during the MD PhD is a 3-year program, is that correct?
That's correct, yes.
So relatively speaking, for just the normal PhD programs, it's usually 4+ years, would you say? Yeah, so do you think there's any difference in the types of research that's being conducted during that 3 years versus 4?
Well, I think it really depends on your research project, and certainly the time constraints can be a bit stressful, I guess. And everyone is worried about finishing on time and such. But like I said, you have the summers before medical school or during medical school to continue with your research. And you don't necessarily have to defend your thesis until you're done the 7 years.
Oh.
Although it is much easier to do it while you're in your PhD portion because you're focused on the medical degree otherwise. And there are different types of projects. So some people who work in, for example, there's a current student who's working in education and learning in medicine, and he is going to defend within 2 years.
Wow.
Whereas some basic science, which is what I do, sometimes takes a long time. So sometimes people are, 4 or 5 years plus in their degrees. So it really depends, and hopefully you pick a project that can give you positive results even if they turn out to be what you're looking for or the opposite of what you're looking for, so that there is some form of accomplishment at the end, whether or not the project sort of works in your favor going with your hypothesis. Yeah. I don't know if that was the answer you were looking for.
Oh, yeah. No, that was good. That was good. So how did you choose your current supervisor?
That's also a good question. So I was always interested in cardiac research, which is what I do now. And like I said, my master's degree was in cardiac biology. But some of my projects during my master's degree were actually related to fetal development.
Oh.
But so when I was looking for a laboratory to do research in, I looked at fetal and placental development, and I looked at cardiac research. And I had read this paper during my master's that came out that's actually very related to my work now, where they showed the capacity of neonatal mice to completely regrow part of their heart, which has never been shown before in mammals. So that was a huge landmark publication in the area. And when I read it, I thought, wow, this is what I want to be doing. And so I looked around at different schools and at different professors, and I sort of found someone who was willing to work with me on that in that area. So that's why I came here.
So I actually know of your supervisor, Dr. Fang, because I took the cardiac pharmacology course during my 4th year, and I attend the cardiac biology journal club that he runs. So can you tell us a little bit of the lab's interest and I guess specifically about your research as well?
For sure, yeah. So Dr. Fang actually covers a broad spectrum of cardiac interests.
He does.
Yes. So there are people in my lab who look at cardiac development. So the heart is formed from a number of different fields of cells in fetal development, and so they look at the ability of those cells to come together and morph into the heart and the way it's shaped. Other people look at cardiac defects in development. So, for example, maternal diabetes can affect the way the heart forms, and you can end up with defects in the cardiac structure. He also investigates cardiac abnormalities with sepsis and other proteins involved in sepsis response. And he looks a lot at nitric oxide, which is an important vascular molecule. And my research is directed more at the result of myocardial infarction or having a heart attack and healing from that. So there's been a lot of research in our laboratory in the past and in present on heart attack and the ability of different mechanisms of minimizing the effect of heart attack. And so you get a scar in your heart when you have a heart attack. And so the goal is to minimize that scar. And so now, with what I mentioned before, with the ability of those young baby mice to recover from cardiac injury completely, I'm looking at ways of how do we extend that to the adult. So can we take the neonatal young phenotype and extend it into the adult age so that when someone has a heart attack, they don't actually get a scar in their heart, and rather they regenerate the cardiac tissue. So that's basically what I do now.
That's pretty cool stuff.
Is it a prevention of the scarring that actually happens in the neonates, or is it a recovery mechanism after that's happened? I guess that would still be preventing scarring, but what exactly goes on in the neonates?
It's a good question. So if you talk about cellular structure and cells within cardiac tissue, there's a number of different cells that make up the heart. So for example, we have fibroblasts, which make the scar tissue or the collagen. There's cardiomyocytes, there's nervous tissue, there's vascular cells, so smooth muscle cells and endothelial cells. So all of those contribute to the response to damage. And in the neonates, so babies, when they're mice, when they're born and at day one, if they're subject to cardiac injury at day one, they don't scar at all. And so for some reason, they can recover without scarring, whereas when they reach day 7 of life, they don't have that regenerative response anymore. So a lot of research currently has shown that the mechanism, one of the major mechanisms by which they recover is with proliferation of their cardiomyocyte cells. So somehow those cells are able to respond and proliferate and then move into where the damage would have been. So no scar tissue is actually laid down there. Rather, the other cells infiltrate and replace any cells that were lost during the injury or cells that died. So there's no need for scar tissue. So it's a proliferation response. So the thing is that in the first week of life, the ability of heart cells to divide is reduced as they get older. So even in humans, I think it's a 0.4% or 0.04% of our heart cells are replaced every year or something like that. So it's really small number dividing, but when in the neonates, they divide much faster and much more of them are dividing. So that can make a difference in terms of responding to an insult. Yeah.
Are there insults to, I guess, a rodent heart that might actually occur naturally in a developing rodent that would cause maybe some kind of evolutionary advantage to having this happen? Or is it just kind of a result of the fact that they're growing and dividing more?
Yeah.
To preempt that, sorry, as the layperson, an insult to the heart, like I'm thinking someone's calling the heart like a bad name. So can we do that one first?
All right. So by insult, I mean some sort of damage that would provoke scarring. So usually we talk about heart attack, which means that the blood flow to a certain part of the heart has been cut off. Others have studied this sort of injury by actually literally cutting off the tip of the heart of the baby. So literally part of their heart is completely missing. So those are the two different types of insults that we talked about, so an injury, really. I've forgotten your question now.
Might there be any kind of evolutionary advantage?
So I think it actually really stems from birth. And when we're born, obviously, the insult or the injury is that now we have to breathe. And so the heart actually remodels when you're born. And the chambers themselves change the flow of the blood throughout the body. And so when we're born and we start breathing, the heart has to compensate for that. So it has to start pumping in a different way. And there's a little bit of more of a heart growth when we're born. So all of those things sort of contribute to the ability of the cells to continue to divide. And so I think that's really where it stems from. I don't know if it's any other type of evolutionary advantage other than the fact that at birth we have to breathe.
So how might we be able to, I guess, bestow this type of advantage on a grown person? So this is kind of probably what you're trying to do. So how would you go about doing that?
That's a great question also. There's a number of different mechanisms that I'm investigating personally. So a lot of people in the literature have published on mitosis markers, so the ability of cells to divide and the cellular proteins that they express when they divide. And so how can we upregulate those proteins and then force cardiac cells to divide in the adults? So that's one area. Other areas that people are interested in are looking at stem cells and resident cardiac stem cells, and how can we activate their ability to promote this proliferation. So there has been some evidence, and I've also gotten some evidence in my research to show that these cells are activated in the neonatal model. So then can we push them to activate in the adult?
Okay. Well, it looks like we're actually cut short on time, so thanks for the heads up, everybody. Thank you so much for coming on the show.
Thanks for having me.
We hope you'll actually come on again, maybe to talk about this research in more depth, since the focus today was a little bit more about your journey through to where you are right now, which is an amazing story. Thank you very much, Jessica, for coming on the show. Everybody, this has been Gradcast. If you're interested in coming on the show, email gradcastradio@gmail.com, and you can check out our radio show and podcast. All of our episodes for the foreseeable future will be put up on gradcastradio.ca or .com. So come check us out. See you guys all next week. Thank you very much.
That's all for this week. If you want to send us some feedback, or if you want to come on the show yourself, email us at gradcastradio@gmail.com. Be sure to hook us up on social media. On Twitter, we're at Gradcast Radio, and look up Gradcast Radio also on Facebook. If you want to subscribe to the podcast is located at gradcast.podbean.com, and it's on iTunes. And while you're there, why don't you leave us a review? It really helps us out. We'll see you guys next week.